Everything we do fits in 40-foot containers, so we can ship it, say, to Caribbean islands. This has the potential of providing electricity. A lot of places, people don't even have any electricity.
This is Energy Cast, and I'm Jay Dowenhauer. I took a week off for my birthday, but we're back, and boy do we have a cool show for you. Today we're talking about wind power with a new take on conventional turbine design. I'll explain in a moment how it is unlike anything you would expect at a wind farm, yet is immediately familiar. It's funny how we can sometimes get stuck with certain designs and fail to see other ways to accomplish the same goals. Smartphones are one example. How did we think we'd ever be able to type messages without a keyboard?
They all have these keyboards that are there whether you need them or not to be there. And they all have these control buttons that are fixed in plastic and are the same for every application. Well, every application wants a slightly different user interface. But what we're going to do is get rid of all these buttons and just make a giant screen. A giant screen. Now,
this was pretty radical thinking when Steve Jobs took the stage 10 years ago, but 700 million iPhones and hundreds of millions more buttonless clones show that it wasn't such a bad idea. Sometimes breakthrough innovations come from outside the multi-million-dollar R&D departments of our largest corporations. It was a farm boy, Philo Farnsworth, who first developed a successful television set, while the brightest minds at RCA struggled to invent a successful prototype. It said the scanning lines that formed the basis of the technology behind television was inspired by the back-and-forth motion farmers make while plowing rows of crops. Just like these notable American inventors, today's guest has developed a new way to look at the design of wind turbines. We all know the design: a tall tower, hundreds of feet in the sky, and a gearbox as big as a house, with 3 blades as long as football fields. What if I told you that this new wind turbine invention came from amusement parks? That is exactly what inspired the Barber wind turbine. Before I learned more about the inventor, the design immediately conjured up similarities to a Ferris wheel. And that's exactly the case. Now, picture a Ferris wheel from a state fair. Rim going all the way around, driven by tires at the base of the ride moving that wheel around. Now, instead of those tires driving the wheel around, what if those same tires were being driven by wind power and running a turbine? That's exactly what this design aims to accomplish, as we'll discuss with our guest right now. Our guest today is Jerry Barber, founder and CEO of Barber Wind. Jerry has led the kind of life that only the designer of a Ferris wheel wind turbine could have. He started out in carnivals with his family, then at 25 became the youngest high school principal ever in Ohio history. He then came back to the carnival business in a way, designing dozens of amusement park rides over the course of his career. That Tower of Terror ride at Universal Studios? That's him. We discussed some of the fundamentals of design, such as, can equipment be light, mobile, and robust? We also touched on the opportunities of this design, particularly in places that don't have many options for affordable, reliable power. I caught up with Jerry at his home in Greenville, South Carolina, a short drive away from me. I hope you enjoyed my conversation with Jerry Barber. We're here with Jerry Barber, CEO of Barber Wind Turbines. Tell us a little bit about yourself, because I was expecting to see a long list of engineering companies that you'd worked for on your LinkedIn profile, and that was not what I saw. You have a very interesting background. Tell us a little bit about that.
Well, I grew up, my father owned a traveling carnival. I ended up going to Ohio State, and then I taught chemistry, physics, and biology. And at age 25, I became the youngest high school principal in Ohio. Then I built some amusement rides on the side while I was still in my 20s, and I licensed those to the largest ride company in the U.S., and they offered me a lot more money than I was making as principal, so I moved to Wichita, Kansas, and worked for them. And I saved up the royalties that they paid for the rides that they licensed from me, and I used it then to start my own company, and decided that if I'm going to build rides, I got to figure out the best place in the United States to do it. And my formula, if you will, was half quality of life and half business reasons. I picked Raleigh-Durham to Atlanta, and I guess I drove down the right streets in Greenville. I liked it the best. I had never been here before, didn't know anybody here, and I moved here. And that was in 1972. And then for 18 years, I manufactured amusement rides. We were building up to 100 rides a year. Well, when I sold that company, it takes about 2 weeks of boredom. You got to find something to do. And I don't know whether he's the grandson or great-grandson of the guy who built the Ferris wheel at the Chicago World's Fair. His family still builds Ferris wheels up in Illinois. And he was coming through town, so I met him and I asked him what he's hauling. He said, a gearbox. So when I go out and look at it, it's the size of a car or an SUV, and it's a gearbox for a GE wind turbine. Well, I know in the amusement ride industry, we don't put those big gearboxes because they're heavy, they're expensive, and they're always breaking down. All your big Ferris wheels have rubber tires running on the rim. So instead of an electric motor running a tire, running the rim, turning a Ferris wheel, I left the Ferris wheel seats off, replaced electric motors with generators, and started building wind turbines.
So the first thing that came to my mind, not knowing anything about you or your background, was this looks like a Ferris wheel.
Well, some of the things on it are from a Ferris wheel, okay? But actually, let's just talk about the prototype. It's an 800 kW. We picked that size because that's an empty market. Once you get above about a 200 kW, all the rest of the designs, except the big offshore ones with the permanent magnet generators, which are uber expensive. Anything above 200 has to have a gearbox. So between 200 and about 1.5 megawatt, there just aren't any wind turbines out there to speak of. It's an empty field, and we have the only big wind turbine that is a standalone. If you ever notice, you always see the wind turbines in 25, 50, 100. And the reason is they need a professional crew, a crawler crane, spare gearboxes to be changing those out, because typically those gearboxes have to be replaced every 3 to 5 years.
And let's talk a little bit about size. The really tall ones, I saw a lot of them when I was doing work in Oklahoma. Those are around 3.
The most common one is a GE 1.5 megawatt.
And we're 800, so we're 0.8 megawatts for those listening at home. The one thing about your design is that it is a much lighter footprint than a typical turbine.
Go back to my amusement ride background. If you go to the state fair, you will see any of the rides maybe on concrete, but it's not anchored into the concrete because they got to move every week or two. You also won't see any cranes setting them up. Cranes are very expensive to rent. So I've used a lot of that technology. We spread our load out on the ground so it takes less concrete. From day one, my whole goal on this whole thing, it dawned on me that electricity is a commodity. And once you get any amount of electricity, it's very easy to change the voltage, the frequency, AC, DC. You can modify it any way you want, very simply. What it really boils down to, how much does it cost you for 1 watt of electricity? Not much else counts. We've looked at all kinds of ways of keeping costs down. The amount of concrete in the ground is an example. Everything we do fits in 40-foot containers, so we can ship it, say, to Caribbean islands. You can ship a container any place in the world for roughly $5,000. If you got to put it on deck, on top of the boat, you almost can move the decimal point one place to the right. Because I've shipped amusement rides all over the world. They can go places. I just had an inquiry from an island in the Caribbean that wanted to put in a wind turbine, but they realized they'd have to change one of their highways just to get those blades down the highway.
Because we've seen on the interstate what it looks like when a blade is traveling down the highway. Oversized load trucks, the whole bit, right?
And everything goes in 40-foot containers. Our blades come apart in the middle and bolt back together. Getting rid of the gearbox, that's 80% of their maintenance. That's a huge cost. Our blades are more like a a glider airplane wing. So we probably have less than a fifth of the amount of fiberglass in our blades that the current big turbines have. And that fiberglass is expensive. And everything on ours can be built by local shops, be it a welding shop, a fiberglass shop, an electrical shop. We don't need expensive machinery, and we can use people already currently trained. So the maintenance on it, almost all of it is doing nothing but just greasing a few bearings. And we say any farmer who doesn't mind climbing up a ladder can maintain it. It's all about simplifying. You don't realize how complex a wind turbine is, because the whole thing has to keep its face into the wind. The blades have to change their angle depending on the wind speed. Once the wind gets to produce more electricity than the generator can handle, you've got to start dumping air. There's a lot involved. Ours have 2 computers on it. All this is done automatically.
One of the things that I thought was very interesting was it looks like with the light footprint, it also seems like it takes a lot less time to assemble. How long would it take to assemble one of these?
Well, let me say yes and no. We set up the first one vertically, and that took cranes, and that was a slow process. But all production models will be put together on the ground, horizontal to the ground, and then we use a gen pole and a hydraulic winch that's built into the base concrete to raise it up.
Like a barn raising almost.
Almost. If you have any major maintenance, you just lower the thing down and work on it. One of our biggest markets will be anywhere they produce electricity with diesel, and that usually costs 25 to 45 cents, where here the cost of coal is 3.5 cents. So that's why on the islands, unless it's a really big island, you won't see any big ones like we have.
This, of course, wasn't on my list, but this reminds me of some of the projects I've developed over the years. I do a lot of water treatment for fracking, and that's something where the fracks move around a lot. It reminds me of your expertise is. The other day I was driving home, I saw a carnival ride on a semi-trailer. Everything has to be mobile, be able to fit tightly, it has to be safe, right? That's a unique set of expertise. Elaborate a little bit more on that, how that expertise, that knowledge is so important for something like this.
Well, 75% of the rides that we built went to the traveling carnivals, 25% went to the big parks. I was surprised. My wife and I drove by a truck stop, and I noticed one of the rides I had built. The ride was built in 1972 and is still out there carrying kids. So reliability and portability, but it does take a lot to get them folded up, and they got to do it quickly with as few man hours as possible.
I think some people think that the conventional wisdom is for something to be mobile, it can't be robust once it's out there in the field.
You got to engineer that into the equipment. You got to keep it simple, reliable, durable. We can be very robust, and we can be tough and still be portable.
You have a curve on your website that shows that you can generate more power at the same wind speed. Reading your chart correctly, it looks like it maxes out around 100 more kilowatt hours at the same speed. How'd you do that, Jerry?
You're talking about efficiency. Those big gearboxes have like a 2-inch hose that pumps oil into the gearbox through a radiator bigger than a semi-truck radiator with a big fan blowing through it. Well, that's wasting heat. Number 2, our blades are much more like a glider airplane wing because we support them at both ends. If you take the big 3-bladed, they only support them at the axle, and the most load on the blade is where it's moving through the wind the fastest. But more importantly, that bigger blade is creating a lot more drag. A glider is very quiet, and it makes it much more efficient.
And I believe you discussed this earlier, but I just wanted to clarify. A conventional wind turbine, the generator is located in the center of the turbine, and with you, it's located at the bottom, similar to how those tires will push a Ferris wheel around at the bottom. In your case, where the tires would be pushing everything around, that's spinning the generator.
Well, obviously the blades are what turns the rim. We have 4 Michelin high-speed SUV tires, and our tires spin at 1800 RPM. So it's simply a shaft from the tire to a 200 kW generator, and our tires turn at 1800 RPM.
The generator is actually moving around faster than a conventional wind turbine, right? It's only
No, the generator on the current wind turbines turns at 1800. Ours turns at 1800. 1500. They have a gearbox.
I think a lot of people think in a wind turbine what's going on is the generator is going around the same revolutions as the actual windmill, but a gearbox is speeding that up.
The only exception to that is some of the offshore now, because to change that gearbox offshore is astronomical cost. Some of them now are going to permanent magnet generators, and the permanent magnet generator is as big as a normal sized room, and they can turn very slow and produce the electricity. The biggest problem, permanent magnets are made from rare earth elements, and the only place in the world they're mining that now is in China.
The one thing I could see with this is that the windmill is not very far off the ground. The center is. Whereas a conventional turbine, the blade is hundreds of feet in the air. Is that a challenge for getting good wind?
Actually, a little bit of it depends on the terrain. Okay, obviously you got a bunch of trees and buildings around you. You got to really get up there. Okay, we're out in the Panhandle of Oklahoma, which it proves the world is flat. Okay, you can see the horizon like you're at the ocean.
Spent plenty of time out there, yeah.
We can make ours taller, but everything on wind turbines boils down to cost. When you go taller, that costs you more money. For us, it's cheaper to make our bicycle wheel a little bit bigger in diameter than it is to add tower height. We may not have the same wind speed down here. It's not that much difference. It's really easy for us to make it taller.
But you don't feel like you need to necessarily, right?
For now, no.
I always ask this question when I encounter a company with an interesting technology such as yours. What is the low-hanging fruit? What is the best opportunity for this technology?
We just came back from the Caribbean island, their first transitional conference. And right now, they have less than 1% of their energy is renewable. They have passed a law that 20 years from now, 70% will be renewable. The Cayman Islands has already approved us, and we're the only wind turbine approved because we lay down in case of a hurricane.
For those who are not aware, I think it's all diesel generated out there, pretty
all
much,
the
right?
Islands are all diesel, and they are really struggling with solar for a reason I would have never thought of. They don't really have the land to put in the big solar farms that the utility would own. If they allowed people to put solar panels on the roof, because electricity is so expensive down there, all your rich people would go out and buy a Tesla battery and solar panels, and they would get off the grid. Someone's got to maintain the grid. The electric bills for the poor people would double.
So this would sidestep the issue of residentially produced electricity, the grid operator stays happy, and then the price of electricity would hopefully go down.
A major study was done by Keystone Engineering. Their analysis says that the levelized cost of energy, we can produce electricity cheaper than any fossil fuel.
You mentioned the islands as an opportunity. I'm thinking Africa. Not a lot of good road infrastructure there, a lot of remote places to get to, not a lot of grid support.
The government has already contacted us. They've got a program where they combine a battery, a diesel, a solar, and a computer. They want to add wind into that, and then they'll put those in some of the smaller communities throughout Africa to try to get an ongoing source of electricity.
What has been one of the biggest challenges for you? It would seem like operators of conventional turbine designs would find your technology disruptive. Has that been a challenge?
No, the challenge has simply been there's not enough hours in the day. If I could figure out how to get the Earth to turn slower, I could get more done.
That's right.
This really is too big of a project for individual take on, but I like challenges.
What drives you to make this happen, Jerry?
It dawned on me, at the big companies, nobody sees the whole picture. They might be an expert on blades, and I think the background with amusement rides. We built 30 different prototype rides in the 18 years I owned the company. That helped a lot.
This is my last part of the interview, and this is free word association. What's the first thing that comes to your mind when you hear all these different energy technologies? Natural gas.
For the fossil fuels, it has less pollution than the other fossil fuels.
Crude oil.
It has a little more pollution.
Nuclear.
A very clean energy, but I don't think it's going to take off or go anywhere because we've already had at least 3 places in the world that has been major catastrophes. Very, very, very expensive up front, but once it's up and operating, it produces tremendous amount of electricity at really a very reasonable price.
Coal.
It can be cleaned up. The problem is to clean it up with current technology makes it too expensive.
Wind.
Well, wind doesn't blow everywhere. and it doesn't blow all the time.
Do you want to amend that with your wind technology?
There are many, many, many places in the world that we fit in perfectly, but we don't fit in South Carolina. There's not enough winds. The good thing about ours is we can compete with coal and natural gas and beat them as long as there is wind.
Solar.
It has taken a dramatic drop in price in just the last, 3 to 5 years, whatever it is. Lots and lots and lots of places the solar works very well. What it really needs is good storage. Storage is more important for solar than it is for wind.
Biofuels.
Ethanol is huge. One, it uses up the food supply. The biggest problem that the farmers have is in the last 50 years there's not been much money transferred to farmers because there's been a constant surplus of food.
Hydrogen fuel cells.
That may end up being very, very useful. The problem is trying to store hydrogen. Been a lot of research done. They've never gotten it, quote, off the ground yet.
Hydroelectric.
Obviously, that's one of the best and most efficient, but there's so few places, and now the environmentalists won't let them dam up rivers and so forth.
Geothermal energy.
And that's perfect. There's 2 islands in the Caribbean that the only 2 that really have good renewables is 2 islands got volcanoes. In some places, that should definitely be exploited because it is a very good way to get renewable energy.
Electric vehicles.
10 years from now, all vehicles will be electric.
Nuclear fusion.
If you can figure out how to do it, it's the holy grail.
Well, Mr. Barber, I can honestly say that I have learned quite a lot today, from everything from carnivals to third world power economics. So I do appreciate your time. Thank you so much.
Thank you for interviewing me.
That was Jerry Barber, founder and CEO of Barber Wind. Jerry says he's gotten help from Georgia Tech, University of South Carolina, and even some old contacts in the amusement ride industry. And remember how I told you that Jerry was the youngest principal in the history of Ohio? He recently attended his 50th high school reunion as the principal. As you can imagine, Jerry had quite a few mementos in his home, and I appreciate Jerry and his wife Tammy letting me shoot up the place like I was doing a feature of their home in Southern living. Be sure to check out those pics of his amusement park rides as well as his wind turbine designs at Host Energy on Instagram and at energy-cast.com. All guests are sent the raw and finished recording the week of release. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 18. Be sure to join us next week when we profile what I do for a living, frack water recycling. Until then, I'm Jay Dowenhauer. We'll see you next time.